Hello everyone, let's try and look at some important topics in series. So first of all, we will have to import pandas because it is a library where we have the series function that we can use to create a series. Let's create a series. A is equals to p dot series. This is how we call the function, and let's give value as 10, 20, 30. Look, now that's my series and I have values 10, 20, 30. I did not assign any indexes or positions, so by default it will have 0, 1, 2. In case I want to specify my own indexes, let's create another series. We can do that at the time of series creation. So index is equals to, let's give indexes as 0 and 3, 0, 2, 3. So look, my series A is that 10, 20, 30 having indexes as 0, 1, 2. Series B is 10, 20, 30 and indexes 0, 2, 3. So can you guess what will be the output when I add A and B? This binary operation will take place on matching indexes. That is, if there is an index 0 in A and if there is index 0 in B, then the values will be added. Like in this example, we will have result index 0 value as 20. But 1, it's only in A, it's not in B. In result, we will have index 1, but the value will be nan. And even if we have a single value as nan in a series, all other, if there are integer values, they will be converted to float. Now let's try and save this here. I'm going to use a function which is count on this series C. How do you know something is a function? Look, after the name, I have used that parenthesis bracket. This indicates that it's a function. Count function will count non-nan values, so it will not count the nan. So it's returned me 2, which is, it counts 20 and 50. There's an attribute, not function, and the name of the attribute is size. Since it's attribute, we will not write this. Okay, and when you press enter, this time it will return me the total number of elements. It's going to count the nan as well. Now there are other attributes that's there for series, like you can give a name to your series using the name attribute, and let's give name as my series. And let's look at A now. We have name as my series. Another attribute is another index.name. This is how you can assign a name to your series ka indexes. Okay, let's write chocolate. Our series, we have chocolate, that is the name given to our indexes, and the name which I've given to my series is my series. Now something which is again of utmost importance is your log and ilog slicing. Let's create another series as A is equals to p dot series and 60. So just like we saw last time, when we create a series without assigning indexes, that by default it will have 0, 1, 2, 3 indexes. If you want to change the indexes, we can do it using the index attribute and assigning as, let's say, A, B, C, D, E, B, C, D, E, F. We have the following indexes for our series A. Let's try and do slicing. Now slicing concept is very similar to the list slicing or the string slicing. Here I'm going to try and show you using log and ilog. Although without using log and ilog also you can slice a series. Now slice means it should fall in a range. For instance, I want to take out 20, 30, 40, 50. Look, we have to remember the indexes. And how we are going to do this? first using the indexes which we have specified A, B, C, D, E, F. Although we have specified these indexes to our series A, we still have that internal indexing 0, 1, 2, 3, 4, 5, which will not be visible to you, and they are known as integer locations. And that will be used when we use iloc. First, let me show you using loc. A dot loc, and the starting index, I want this 20 value, so starting is B. It's a string data, that's why within quotes, then colon. This is how you specify a slice. After that, the stop value. The stop value is 40. Its index is D. So I'm going to write D. Then it's going to give me a slice out of that A. Remember, in loc, the starting and stopping both are inclusive, hence 20, 30, 40 is also there. To do the same thing using iloc, then I have to give the integer indexes. That is for B, starting with 0, this is 0, this is 1, so starting is 1. For 40, it's D, which is 0, 1, 2, 3. But unlike in loc, the stop value is exclusive. So if I give 3, this won't be included. So it will stop before 3. This is what's going to happen. But I want 40 as well, whose integer index is 3. So I got to specify here one more value so that 3 is included. Now the same logic applies for loc and iloc slicing in your data frame as well. Well, this was a slice. Slice means, as I have already told you, it should fall in a range. What if you want selection like 20, 40 and 60? In that case, using LOC within third bracket, there you will specify the values. For now, this is LOC, so label based indexing. For 20 is B, 40 is D, and 60 is F. So B, D, F, and F. In case I want to do the same thing using integer locations, so we have to find out what is the integer location. For B is 1, for D is 3, and for F is 5. So 1, 3, 5. And now let's try and look at some important points related to data frames. You must go through how to create a data frame from a nested list, from a dictionary of list, dictionary of series, from a dictionary, etc. I have already created a function to create a data frame, so I'm going to use that. So I have a data frame df which looks like that. Let's try and change the indexes for our data frame as and F. Now look, I have my indexes as A, B, C, D, E, F, and the columns as name, math, science, IP. Now it's not necessary that my indexes has to be all letters. If I want values as 10 and 40 as well. So this is now my df having the following indexes. Up, suppose I want Shrek, Dinah, Joker, Bugs, name, math, science using loc. Now loc is label based indexing. We'll be using the labels which we have given for our rows and for our columns. So df dot loc within third bracket, Shrek index label is B, and how far we want till bugs, suppose, then we'll have the bugs. If you see, the label is 40, so we are going to write 40. This is your row slice, and in the column slice we want name, math, science. So the column is name, column math, sorry, ending is science, right? And this is going to fetch me the rows starting with B 10, D 40, and the column slice is name, math, science. So look here, this was row slice stop, this was your row slice, and here start value is B and stop value is 40. So starting with B 10, D till 40. In log, you have to remember that the start value as well as the stop value both are inclusive. Same thing for the column slice as well when you're using log. Name was the starting value. We want our slice to start from here, this column, and we want it to end at science column. So this is stopping value, which is also inclusive. So starting from name will include everything that's there in between till the stopping value. This only happens with log. When we want to do this using ilog, then we have to specify the integer locations, which is not visible to us, but that's there. So if you want to do the same thing now using ilog, we have to specify the integer locations. Now we may not be able to see the integer location, but that's there. For columns, it starts with 0 for the first column, then 1, 2, 3. Same thing for the rows as well. 0 for the first row, 1, 2, 3, so on. So when we want a slice starting with shrek ending at bugs, we have to specify the integer index, which is 0, 1 for the row slice, and bugs it's 0, 1, 2, 3, 4. For the column, the integer location is 0, 0, 1, 2. We are stopping at science, say 2. But unlike log, in ilog, the stopping value is exclusive. So if I mention 4, which is bugs, the slice will end 1 before this index. For your column as well, the starting 0 is inclusive, but 1, 2 will stop before the stopping value because the stopping value is exclusive. So what we are going to have is we are going to have 1, 2, 3 integer rows and 0 and 1 the integer columns. So if we want what we wanted, then we have to specify one more index. What happens if we don't specify the ending for a row slice? Then all the rows starting from 1 will be included, but just the 3 columns. What will happen if I do not specify the start and stop for my row slice, but I have indicated the start and stop for my column slice? So all the rows will be included, but will only have 0, 1, 2 columns, which is name, math, science. In case I do not specify any start value or any stop value, what then? Everything will be included. So the same as not specifying any start value for the column slice. So well, this was all about slicing. What if we want selection? That is, maybe I want Batman, Joker, just math and IP marks. This time I cannot do slice because it does not fall in a range where I can specify the start and stop value. In this case, using .loc, I have to specify within another bracket the selection for my row. That is, for Batman it's A, and for Joker it's D. That is your row selection, followed by comma, and then within another third brackets you have to specify your column selection, which is maybe you want math marks and you want IP marks. Then this will fetch me just the selected rows and columns. Notice the difference when we are doing slice. This was a row slice, this was a column slice. With ilog, we mentioned the integer locations, which we cannot see if we have specified our own row indexes and column names, but this will be there, and the stopping is exclusive. But note, the slice is not given within another third bracket. Same thing here also for column slice. But when you're doing selection, then you have to specify within third bracket, comma separate values. Let's try and apply the count function of data frame. It will return the count for each column, number of values. Let's try and change what's there in a math. That is row A math intersection is this. So Batman's marks, we are going to change it to none. And we have the data frame where Batman marks is none. You can immediately notice that all the marks that's in math column is now changed to floating point value from integer. Now when we try and apply the count function on our data frame, then remember count function counts non-nan values. So for math column, it's not counted this nan. If we apply size attribute with data frame, remember when we applied size attribute with series, it returned the number of elements. The same thing happens here as well, it will return the number of elements. So how many elements are there in this data frame? It's the number of rows into the number of columns. 1 2 3 4 5 6 6 4s are 24 elements are there in my data frame. There's another attribute called shape. Look, I'm saying attribute, so we will not give this brackets. Now shape will return you the dimension or the order of the data frame. There's number of rows and number of columns in a tuple. Something called ndim attribute. It returns you the dimension. Now it's a two-dimensional the structure, and hence we have 2 here. Let's go back to the count function. Now why is it counting column wise? The reason is by default axis is 0. Now axis 0 represents row axis. In other words, in more technically speaking, it represents the axis where you have marked the rows. So look, this vertical, not horizontal, the vertical one. This axis is where you have marked A, B, 10, that is the row indexes. So this axis represents row. Axis 1 represents column axis. Technically speaking, this one is the axis where you have marked the columns, and hence it's moving horizontally. So when I write df.count axis is equals to 0, it will count row wise. Axis is 0, so row wise means it will move vertically downwards, because see, this is the row axis and you're moving row wise. So it'll give you the count for each column, and that was what was happening here. In case I do 1, which represents column axis, that is the axis where you have labeled your columns, you're moving horizontally, so it'll count horizontally like 1 2 3 4 1 2 3 4. So count column wise, you can say. Then it will give us the count as 3 for A, B for 4. So in each row, how many values are there? It will be returned the count of non-nan values. In case you want to count just for a particular column, then you have to mention that column. df.math.count, df.math.size is an attribute will return you the number of values, where our data frame was this and our math column was that. We can also sort our data frame using values function, where we specify the name of the column. Suppose math. Then what this will do is it will arrange my data frame in the ascending order of math marks. If I want it to be sorted in descending order, then it has to be ascending parameter is equals to false. How do we add a new row to a data frame? Let's see first new column. It's very simple. We have to give the name of the data frame and then the column name, suppose D is equals to, in case we specify just one scalar value, then that will be repeated as many number of rows that's already there in my data frame. Or if you want to specify some different values for different rows, then you have to give it as a list 89, 100. In order to add a new row, we have to add this way. Let's specify our index as 100 and the values as, now we have a new row 100. So to delete a column, there are three methods available. One is using just the pop function and specify the name of the column you want to delete, maybe IP, and look, whatever is deleted, that is returned. The pop function will return what's deleted. If we check our df, IP is gone. We can use del method to delete a particular column as well. Let's now try and delete the column D. It will also delete, but it's not going to return. It's not say that it's deleted this column. If we check, that D is also now deleted. There is a function called drop. Now drop is specifically to delete rows. So if you want to delete a column using the drop function, you have to mention the name of the column, suppose science, and then you have to mention the axis as 1. So either you can write axis is equals to 1 or just 1, and 1 represents the column axis or the axis where the columns are labeled. Then the drop function will delete the column signs. However, the drop function does not make deletion permanent. It's because if we check df, we now see that science is again there. So if you want this permanently, then what you can do is when you're dropping this, you can mention in place is equals to true, but I don't want to do that. So these are the three ways which you can use to delete columns from a data frame. Now, how to delete a row? Well, I just told you that the drop function is specifically to delete rows from a data frame. So df dot drop, just write the name of the column, the row which you want to delete. Row whose label is F I want to delete. So we see that that row F is gone. But this is not a permanent one. In case you want this to be a permanent one, what you can write is in place is equals to true, and now that row will be deleted for forever. Okay, so these are some of the topics which are very important. Also, go through what's there in the syllabus, go through data visualization, go through societal impact,